My name is Galen Erickson. I'm a feedlot extension specialist and a professor in the Department of Animal Science here at the University of Nebraska. We've been part of a team effort that's focused on ways to evaluate methane production by beef cattle. In fact, we wanted to try some new methods that really hadn't been done before, mostly because most of the previous studies have been done on relatively small numbers of cattle in very confined head boxes, for example, where they got to be confined in this area to see how much methane they produce. So we were doing a study where we were looking at our individual feeding facility, and it has feed bunks where the cattle come in to eat. And as you can see, there's bags that we would fill with air as the cattle were in the bunk. And instead of us filling it with air, what we were actually filling those bags with is a combination of air and respired breath from the cattle. And what you have to appreciate is that the respired breath has methane and CO2 that the cattle, of course, are producing. So we use that method to try and evaluate different diets and different strategies to cut the amount of methane that cattle are producing. So we've done numerous growing studies and finishing studies with beef cattle. And one of the first studies we did, we looked primarily at, we looked at a lot of different treatments because we had a lot of different cattle, but we primarily looked at the effect of forage quality on methane production. And in general, the cattle fed low quality forages produce more methane, and that can be observed in those lines that kind of clump and are above, and then the lines that are kind of clumped and below are cattle fed a high quality forage diet. So there's no doubt that similar to previous work with intensive head boxes and such, there was very good separation. Well, what's really important when we evaluate methane production by beef cattle is are you talking about how much they produce in a day, how much they produce per unit of weight gain, for example, or productive function, or is it how much they produce per intake? So there's really three ways that we've evaluated that. And so the blue lines or the blue bars are amount of methane per day. The red bars are when you look at high quality and low quality forages with amount expressed per kilo of gain or per pound of gain. Either way, the graph would look the same. And then amount per unit of intake. And so the high quality plus is with rumensin, which has commonly been evaluated to cut methane. The high quality negative is without, and then you have low quality forages with and without monensin. So this is very similar to previous work. The other thing then we did to compare to was to look at a traditional system, what we call the head box system, where cattle are actually tethered and put into this box to measure the amount of CO2 and methane that comes out. And then we compared those data with the same treatments, if you will, to what we observed in the larger barn where we're collecting respired air. And for forage-based diets, there's actually pretty good agreement. We saw very similar methane to CO2 ratios. We actually saw pretty similar methane amounts per day, whether they were in a head box or whether they were in our individual barn. Especially for low quality forages, there's very good agreement. CO2, similarly, low quality forages, very good agreement. There's a bit of a range on the high quality forage diets because we had actually different inclusions of distillers in the individual barn. And then they ate a lot more feed if they're fed a high quality forage diet, which is to be expected. We've done very similar work in feedlot diets, and to be honest, as others have shared, there's probably more opportunity to have a more dramatic impact on the amount of methane being produced on cattle fed forage-based diets. But we also want to evaluate finishing or feedlot type diets. So we did that comparison between cattle fed in our individual barn versus in head box. Not quite as good of agreement between those two methods. And so as you can see, there's really not such good agreement on the absolute amount of methane per day as liters per day. For cattle fed what we've labeled here as a control or corn-based diet versus a modified distillers grains diet. That's what MDGS is. So those are the two different diets we evaluated, both in the barn and in the head box. While there's not good agreement between the two sets of numbers, the difference between the relative differences, if you will, between the diets does agree pretty well. We just don't feel that's as robust of a method as what we need for the future. And so we've more recently equipped a couple of our barns where we'll actually measure total airflow in and total airflow out so that we can more robustly measure methane emissions. So we're quite excited about the future opportunities for helping beef producers with mitigating methane. Again, I would reiterate, as long as producers continue to work on productivity, they're helping reduce our methane emissions from our beef cattle industry. And so continue to do what you're doing today, but hopefully in the future we'll have even more options for people to be able to cut how much methane's naturally produced by beef cattle. For more information, you can visit our websites. We put all of this information together in packages, and so producers can learn more about what we're doing and all the different experts from across the country.